We've conducted a lot of research in the fields of topography and 3D surface capturing to test certain elements of the installation. This project is about creating a new way of topographical imagery. We are able to capture the surrounding mountainscape. We've also created a terrain model using the SRTM digital elevation database from NASA, where we transformed satellite images into digital STL 3D files, from which we then could conduct further testing of the installation. The concept came from an actual, really pragmatic idea where you lay a grid with only horizontal lines on top of the asperous terrain to create a sort of visual representation, or rather abstraction, of the actual topographical modules. It's a new way to approach nature, and it's almost closer to examining architecture than natural constituents. So we are almost like creating a mold for which we use light as the molding material instead of a physical entity. In our first tests, a scan line is projected onto natural terrain. It allows the light to curve and fold over protruding sections and assist the viewer to obtain a reference in which our brains then can analyze the genuine depth and the height of the projected area. The resulting intervention was more like an expedition than a usual art happening. We had to carry all of our equipment with us, reaching from image capturing tools, power supply material, to our laser imaging equipment. And the weather was also one of the most challenging parts of the expedition. We had winds up to 75 kilometers an hour and sudden cloud bursts where you had to make shelter for all of our equipment in just a few seconds, and that's just one of the hard parts of working in the mountains. Now, working in the mountains while it's dark, it is quite hard because we have no assisting street lights or city lights which would illuminate the sky, so it's just pitch black. The results came out exactly how I imagined them, and it's amazing to analyze these images and think about the structures at play.